All right, we're going to continue here with this next question. One variety of blueberry plant yields an average of 130 blueberries per season, but of course it's a plant and there is quite a bit of variability from plant to plant. No two plants produce fruit exactly the same. So one measure of this variability is what's called the standard deviation. And for these plants, it's approximated to be 16.4 berries. And in this case, we can have a fraction of an actual berry because what we're talking about is how far off from that 130 are most plants. Most plants don't get any farther out than 16.4 on either side of 130. So 146 or 114, roughly speaking. So given that a plant is giving off or yielding B blueberries, we can calculate how usual or unusual that is by computing what's called its z-score. Right? A z-score is something we'll talk about in statistics next year. We don't need to know what that is just yet, but it is just one of the numbers we calculate in statistics that compares amounts of things. We can use this formula for right now. All we have to know is the formula, and here we have an example. So if a plant is yielding 130 blueberries, it would have a z-score of 0. If B represents the number of blueberries, 130 minus 130 would give us 0. 0 divided by 16.4 equals 0. A plant with 138 blueberries would have a z-score of 0.48. We would just do the calculation. 138 minus 130 divided by 64, we get 0.48. All right, so we're going to use this formula on the next slide here. And we need to decide, do we have an equality, an equation, or do we have an inequality, where we might have more than one answer, or a minimum amount of some sort. All right, so we're going to take the z-score of a plant yielding 140 berries. So again, we go back to the equation, 140. We're going to take 140 berries, subtract 130, divide by 16.4. So that is an equation. We're going to move it over there. That is an equation, and we want to know the z-score for 140 berries divided by the 16.4. We want to know that amount, and I'm going to put parentheses around it just to make it more clear. Math is all about clarity and making sure that you say exactly what you mean. All right, and then we can just go to our handy-dandy calculator and figure out what exactly that number is. So 140 divided by 140 subtract 130 is 10. Don't need a calculator for that part. Divided by 16.4 gives us a z-score of 0.61. 0.61. So I can say z equals 0.61. All right. B, if the z-score is negative 0.7, what is the yield? Negative means below average. Okay, so we have an exact z-score. That is another equation. And this time we know the z, so we can put in negative 0.7 equals, and this time we don't know the b, so b, subtract 130 divided by 16.4. We divide there, divide by 16.4. And now we need to work our way backwards, so we need to undo these parts. We need to undo the division, we need to undo the subtraction. And we talked about that with equations a lot. So let's go ahead and do that. We'll start with our negative 0.7. We're going to start with that, times 16.4 to undo the division. We're going to multiply. And then we're going to add the 130 berries, and we get 18.52. So the number of berries is about 118. B is about 118. Like that. All right. Question C. A plant with a z-score of 1.96 is considered plentiful. What yields of blueberries will be considered plentiful? Now this says yields, which means more than one. And that tells me that we could have more than one answer, which means it's an inequality. All right. So z-score would be 1.96, right? And we need the number of berries to be equal to that, or maybe more, right? Or greater, right? So this has to be or greater, equal to or greater. And so again, we're going to have b subtract 130 divided by 16.4, and that will give us how many berries, what yield of berries will be more than 196. Okay. Let's go ahead and do that with the calculator. 1.96 times 16.4, right, plus 130 gives us, has to be greater than 162. So the number of berries, the yield of berries would have to be greater than or equal to 162 in order for us to get that z-score or higher. And likewise with question D, a plant with a z-score between -1 and 1 is considered ordinary. What yields of blueberries can be considered ordinary? Again, yields and talking about an inequality here, because there's more than one result. There's more than one possibility for that. There's a minimum number and there's a maximum number. We're trying to find out what would that number be. So in this case, this is going to be a little kind of interesting. We start with -1. That's our z-score. Our berries have to be greater than or equal to that. So I'm going to put again our b minus 130 divided by 16.4, but it also has to be less than or equal to +1. So we actually have two inequalities here. And so we need to figure out what yields of berries. So in one case, we want to know what number is, what's the minimum number, so what number is less than or equal, and what number is greater than or equal. All right? What is that? What number does B have to be in between? And so we're going to have to solve essentially two equations here, two inequalities. We'll start with the -1. Okay, -1 times 16.4 plus 130, and we get 113.6. 13.6. So B has to be larger than 113.6. Repeat that for +1 times 16.4. Right, which is just 16.4, obviously, plus 130 gives us 146.4. 146.4. So the yield on the blueberries has to be between those amounts. We essentially have two inequalities there. All right, moving on. Gretchen walks a treadmill. The number of calories per mile she burns is given by the equation C equals 125 m, where C is the number of calories she burns and m is the number of miles that she walks. All right, so we're going to do this with Desmos again. We need to draw a graph showing the number of calories Gretchen burns if she walks 1, 0, 1, 2, or 3 miles. Okay, and we're going to paste that graph in here, as well as we're going to figure out some parts of this question here too. So I think I've already got this built up here. I do. So I'm going to redo it just so we have it. All right. We have a table. From the story problem, we have a table. We have an equation. Let's do the equation first. C equals 125m. Right, and it draws the line for us. I've already adjusted the axes here. The horizontal axis is the number of miles. The vertical is the number of calories she's burned. That's in the wrench menu over here. Right? And now we're going to add a table. And X is our independent, Y is our dependent. X is our miles, Y is our calories. And we want 0 miles, 1 mile, 2 miles, and 3 miles. And what's it in there for us? Well, 0 miles would be 0 calories. Because that's all it is. 1 mile would be 125 calories. 2 miles times 2 would be 250. 3 miles would be 75. You can see all 4 points drop right onto the red line there. They're all right there. Okay. And I'm going to hold off and copy and put my graph in a little bit in a second. What I'm going to do here is I'm going to go to this question, and I'm going to answer questions B and C. How far does she need to walk to burn at least 200 calories? Set up and solve the inequality. Well, 200 would be the minimum. So whatever has to be greater than or equal to that. 200 must be less than or equal to whatever amount is. Well, that's just the 125 times m. So whatever miles she walks has to be bigger than, has to burn at least, at minimum, 200 calories. We could also turn this around. 125 m is greater than or equal to 200. Either one. Okay. And we can just find that answer by dividing. So m, the number of miles, needs to be greater than or equal to 200 divided by 125 gives us 1.6. 1.6 miles. Okay. And that's what's noted on the little x here. To put that on your graph, we'll go back here, and we can just put in the xy coordinates. Our independent is the number of miles, which is 1.6. The number of calories burned, what did we say was that? That was 200. And we can put a label here to highlight it, since that's part of the assignment, is to highlight it. 1.6 comma 200, look, it's right there on the line. So we're good. And now, we can save it, give it a name if you'd like. We're going to copy, and we are going to go here and paste. Just like that. All right, one more Z question. Okay, another Z formula. This one's about potato chips. Okay. Same idea. Do we have an equation or an inequality? What is the Z score for a bag of chips weighing 200 grams? Okay, 200 grams, we just take our formula. Z equals 200 minus 207 divided by, what was our number again? Always go back and check if you're not sure. 3.8. 3.8, and we can use our handy-dandy calculator to figure that out. 200 minus 207 is going to give us a negative 7, and negative 7 divided by 3.8, negative 7 divided by 3.8 gives us a Z-score of negative 1.84. Z equals negative 1.84 or thereabouts. Okay. Question B. About 3/4 of all bags of chips will have a Z-score greater than or equal to negative 0.67. Okay. What weight has a Z-score of negative 0.67? All right, so we're going to use our formula again. We're going to start with negative 0.67 equal to, what letter do we use there? What do they use in the formula? B. B again, for bags. B, oops, B minus 207 divided by 3.8. And we're just going to work our equation backwards. So we're going to start with negative 0.67 times 3.8 plus 207. Working backwards, 204, about 204. So that would be B is about equal to 204. That'll be grams again. Right. A standard Z-score between negative 1 and 1 is ordinary. Which range of weights are considered ordinary? This is just like the other one we did, where we have a negative 1, which is going to be less than or equal to our B minus 207 divided by 3.8, which is less than or equal to positive 1. And we've got basically two equations there. And we're going to find a less than or equal to B, less than or equal to some other number there. We're going to figure what those two numbers are going to be on either side. So we've got two equations here, two things to solve. So we'll start with negative 1 times 3.8. Oh, I got my numbers off here. Times 3.8 plus 207 gives us 203.2. And we repeat that. And we get 210.8. Finally, if one serving size is 28 grams, then how many servings are in a bag that weighs 207? So that's 207 divided by 28. which gives us 7 servings total. All right.